All right, boys and girls. Today we're going to do kind of a writing and solving exponential and logarithm equations recap. Some of this is going to be familiar to you. For some of you, it's still going to be a little unknown, but I'm going to try and work through a whole example to hopefully give you a little more guidance and answer some of your questions. So let's take a look at this first one. You should have this paper in front of you as well. Sorry if my work gets kind of sideways. Not a lot of room to be working here. So let's go ahead and read number one. On the day of his son's birth, an investor deposited $2,500 into a savings account that grew by 5.3% per year. How old would the son be when his account reaches $15,000? All right, so a couple things we're going to highlight real quick. An investor deposited $2,500. Let's try this. Investor deposited $2,500 into a savings account that grew by 5.3% per year. How old would the son be when his account reaches $15,000? So that's what we're trying to get to. So immediately, we should be thinking in terms of an exponential function, f of x equals a times b raised to the x. All right, in this case, the a value is going to be our initial amount, which is going to be our $2,500. All right, times our b, and since it's growing, we know that the rate has to be above 1, so we would say 1 plus, and then 5.3% written as a decimal would be 0.053 raised to some amount of time, in this case years. All right, so that would be my equation, f of x equals that, but I'm going to go ahead and set it, instead of just f of x, I'm going to set it equal to $15,000, because $15,000 is the amount we're trying to get to. All right, so yes, I could graph this, right? I could take the left side, I could put it in y equals, I could take the right side and put it in y equals, and I could treat this like a system of equations. But if I want to solve it algebraically, my steps would be to first divide by 2,500 on both sides. That's going to get rid of the 2,500 there. On this left side, it's actually just going to get rid of those zeros, and it's going to simplify to 150 over 25 equals 1.053 raised to some x value. If you're not sure why we got 1.053, if you look over here, and I'll circle it in red, 1 plus 0.053 could be put together as 1.053. So it's not wrong either way, but putting it together as 1.053 helps us a little bit better. And then I know I'm solving for an exponent, and in order to solve for an exponent, I have to write the exponential equation in terms of log, right? I have to find the inverse per se. So we would write this as log with a base of 1.053. And remember, we're isolating the exponent. So here would not go the exponent. Instead, we would put in parentheses 150 over 25. And that would equal our exponent. All right, so now that we have our exponent by itself, we can jump over to Desmos. And if you're not familiar, we just type it in, log. I can change my base. So we're going to go log with a base of 1.053. So log base 1.053, arrow over. And in parentheses, we're going to put what we had simplified to, which would be 150 divided by 25. And I know some of you are probably saying, well, 150 divided by 25 is just 6. And you're right, it is just 6. But I don't have to simplify it if I can keep the fraction the way it's supposed to look, right? So just so we're on the same page, if I go back over here, if you did simplify it as 6, you could say log base 1.053, arrow over, and just say 6, and we'd get the same thing, right? So 150 over 25, we could reduce it. So what that tells us, if we go back, so we'll call it 34.7. So when we go back over to our assignment, we can say x equals 34.7. And notice that the question says, how old would the son be when his account reaches $15,000? So we're looking for the age of the son. And since it started on the day of his birth, right, he would be approximately, we could round up, 35 years old. Right, that's what this information is giving us. All right, lots of math. If you're just looking at this and you haven't paid attention and you haven't been trying to follow along, then it looks very confusing, I'm sure. All right. All right, so let's look at part A, or question A, extension A, however you want to look at it. Now it says, how old would he be? So let's get our pen back out. Let's go orange on this problem. How old would he be? So we're still looking for an age when the account reaches $15,000, which we already did, if he was earning 13.4% this time. All right, so again, I can jump into f of x. So it's going to look just like our first equation with a few differences. So we're going to go f of x equals, I still started with the same number, which would be 2,500. But now I'm growing by 13.4%. So 1 plus 0.134 raised to some x value. And I'm going to go ahead and put everything together. Right, so we said 15,000 equals 25. I'm sorry, 15,000 equals 2,500 times 1.134 raised to some x value. Now, if you pay attention to this part, right, and we're going to kind of shortcut it. If the 2,500 didn't change and the 15,000 didn't change, this 15,000 and this 2,500 through the same steps would reduce to the same thing, right? And so those went directly into the 150 over 25. So the only thing that we have to look at changing, let's pick a little color that'll stand out, is this right here. All right, and that's going to be taken over by this. So I'm skipping some steps to help you see the process is the exact same as the first one. So if you had to look back, you could. So we're gonna make the changes that we said, and we're gonna jump ahead. So log, now with a new base of 1.134 of, again, 150 over 25 equals our new x, which would be our new age since we're starting at birth. So I'm going to pop over back into Desmos. We said the 150 over 25 wasn't changing. The only thing that changed was our base. So I can go immediately down to our base, maybe 1.1. Nope, it's going to make me rewrite it, which is okay. Log base 1.134 arrow out of 150 divided by 25. Arrow out, close my parenthesis. And now we have x equals 14.25. Right, so I'm going to bounce back over. And in this case, x equals 14.25. So we could say approximately 14 years old. Boom. All right. And then lastly, I'm going to work through part B with you. And so I want you to start seeing things. I want you to start noticing what's changing, what's not. Because the more comfortable you get with these problems, the easier it's going to be for you to relate certain parts of it together. So I'm going to go gray. If 13.4% is exactly what I used last time, then it should relate to this. It should relate to this. All right. So what would be changing is the 50,000 that we want to equal to now. So my function, as I write it, should be f of x equals, we're still starting with $2,500. We're still increasing by 13.4%, so 1.134 raised to some x value. Now we need that to be equal to $50,000. My steps would be the exact same. I would divide by the 2,500. All right, so I'm going to divide both sides by 2,500. Divide by 2,500. This is going to go away completely. 1, 0, 1, 0. And now, right, I'm rewriting it the exact same way, but we already know that in order to solve, I'm going to have log base 1.134. But now it's going to be of 500 over 25 instead of 150 over 25. And that would give me my x value. All right, so we can bounce back over to Desmos. Log, the base isn't changing. The only thing that's changing is the 50,000, which was reduced to 500 over 25. And there's the x value we get, which we'll call it 23.8. So x is going to equal 23.8, which we will round to 24 years old. All right, so go ahead and try number 2 on your own.